Financial Modeling, Topic 9, Section 4. In this section, we're going to understand mortgage valuation, duration, and convexity. Now, we said that the value of any bond is the present value of all future cash flows discounted at some interest rate R. Now, for a normal coupon bond, that just consists of contractual coupon and principal payments or final par payment. Now, when we apply this to a mortgage, what we find is it's typically a 30-year maturity. That makes a frequency or number of payments of 12 per year. So there's 360 payments for a typical 30-year monthly payment bond. Also, the cash flows for a mortgage are a little more complicated. In theory, homeowners would hold on to this bond for this mortgage for 30 years, and it just looks like a coupon bond. However, mortgages can be prepaid without penalty at any given point, and the homeowner can also default on the mortgage. This makes the cash flow estimate of mortgages very, very difficult. The cash flow at time I of any mortgage payment consists of the scheduled principal and interest. Now that's if just everything's going normally, you just pay your principal and interest of your mortgage. However, it may include partial principal payments. So say you mail an extra $500 in with your mortgage payment, or you're paying an extra payment this month to pay off some additional principal. Or you could have a full prepayment due to refinancing with another lender. So say you take out a 30-year mortgage at 5% and interest rates fall to 4.5%. So what you do is you just mail back the entire principal amount and pay off your current mortgage. That shows up as a full prepayment of the mortgage, and it ends in, say, a year versus 30 years from now. Now, that prepayment could happen, one, rates fall, or two, the person just simply sells their house, cashes out or refinances. So as that we call it a cash out refi. So say they need to send their child to college, what they might do is just refinance their house, take an extra $50,000 in principal to use for college, or the mortgage could default. Say the homeowner sells their house for what it's worth and mails back a check for what it's worth. So for all of these reasons, the cash flow of a mortgage is very hard to calculate or estimate throughout the 30-year life of the instrument. Now we talk about the duration and convexity of a mortgage. Let's first talk about a normal non-callable bond. A non-callable bond will have this convex shape, all right, just due to the compounding or the present value discounting of cash flows. You're going to get an inverse relationship that's convex to the origin. However, a mortgage, when you go ahead and estimate these cash flows for different interest rates, what you wind up is getting a function that looks like this. Now, this is a concave function mathematically. However, in finance, we never use the word concavity. We use the word negative convexity for reasons I don't understand. However, what we say is mortgages have negative convexity. Now, let's talk about the desirability and undesirability of convexity. Convexity is a good thing. All else equal, I'd rather have a bond that's more convex because for any given rate change, it's worth more. So, using that logic, negative convexity is a negative thing. I prefer not to have negative convexity. So, mortgages have negative convexity. Let's explain why, and also explain what the duration of a mortgage is. Now, I could just use my duration function to calculate the duration of a 30-year bond that makes 12 payments per year. And that duration could be something like 10 or 15 years, depending on the interest rate. However, once you estimate the cash flows and the changes of people's behavior relative to prepayments, what you find is for mortgages, the durations tend to be closer to 3 to 4 years, which is about the duration of a 5-year non-callable bond. The reason why the duration of a mortgage is about 3 to 4 years is people tend to only hold on to their mortgage about 3, 4, sometimes 5 years due to moving and prepaying and defaulting and so on. So when you take kind of the average cash flow of that 30-year instrument with people's ability to prepay at any time for any reason, you get a duration that's closer to a 5-year bond. And you have negative convexity. So having explained why the durations of mortgages are much shorter than you would predict using that function, we can't use that function to calculate mortgages. Let's talk about why it has negative convexity. Again, one interpretation of duration is a slope of a line at its current price-yield relationship. So it's the slope. One interpretation of negative convexity for a mortgage is that if rates drop from this level to this level, this slope is going to go from this slope to this slope. And let's talk about why this slope would fall. Again, let's think about the slope as the duration. When this mortgage was first issued, would say it had a duration of 4. However, if rates fall, people are going to start prepaying their mortgages. They're going to start mailing back the entire balance of the mortgage, that 30-year mortgage, in, say, 3 to 6 month time period. Therefore, the duration could fall to maybe 1 year or a half year or 3 months. So the fact that the life of the mortgage, which originally was estimated at 3, 4, or 5 years, if rates fall, it may be less than 1 year. That ability or that property of the duration or lifetime of the bond to fall as interest rates fall because people prepay is one interpretation of negative convexity on mortgages. It says that as rates fall, the durations fall, and that's the graphical shape of this negative convexity. Another similar interpretation is if rates rise, the slope or duration rises because people are going to hold on to them a little bit longer. So mortgages have durations closer to 5-year bonds, non-callable bonds, because homeowners can prepay at any point in time, and typical homeowners hold on to them for maybe 3 to 5 years. And it has negative convexities because as rates fall, the duration falls, people start prepaying, and as rates rise, the durations extend as people hold on to the mortgages longer. So that gives a good interpretation of duration and convexity of a mortgage. Another property of mortgages is that mortgages have limited upside potential. Think about if you buy a bond at some discount rate and the rates start going down, you can make a lot of money as the bond increases in value. However, with mortgages, say you bought a mortgage as an investment. As rates decline, you're going to gain value, but your upside is limited to about par. So what does that mean? If a homeowner borrowed $100,000 and you bought this mortgage through the bank, you bought it from the bank. If rates start falling, the present value of cash flows go up. However, as rates start falling, it's more and more likely that that person is going to mail back or prepay the mortgage in full, and they're just going to prepay the full amount at par. In other words, if they borrowed $100,000, they're just going to send a check back to $100,000. So the appreciation of a mortgage is going to be limited to about par because homeowners can always just mail back the entire balance of the mortgage without a penalty. So that's another way to interpret the slope of the upside is limited to par, to about par for mortgages because of the prepayment option. So this was sometimes called the curse of negative convexity of mortgages. So why is negative convexity so bad? Because as rates fall, you don't get the normal appreciation of a normal bond, a non-callable bond, because mortgages can always be prepaid at par, so you have limited upside. Worse yet, as interest rates fall, homeowners start prepaying their mortgage, sending the money back to the bank. Just when interest rates are falling, the bank is receiving more money to reinvest at that lower interest rate. So we say that mortgages have significant reinvestment risk. When the cash flows start coming in, they'll increase as rates fall, and that's the time when you reinvest at lower subpar rates. And as rates rise, the mortgage value decreases more than non-callable bonds because the duration starts getting longer. And the people start holding on to their mortgages longer. So just as rates rise and the banks want to issue new mortgages at those higher rates, that's when the homeowners hold on to their money even longer and you have less money to lend out. So this is called the curse of negative convexity of mortgages. So in this topic, we talked about mortgage valuation, duration, and convexity. In the next topic, we'll talk about the VAR, or value at risk, of a bond using duration and convexity.